In example 1, the idea here is to take the three values, 20 degrees, 100 degrees, and negative 40 degrees, and substitute them into this formula. This formula converts anything from Celsius to a temperature in Fahrenheit. So of the three temperatures listed, those are all in Celsius. So we're going to make a substitution for those in place of C. And the goal is to find the corresponding value for F. So this is evaluating an expression. I'll start with 20 degrees Celsius. The idea is you take your formula, F, and any place that you see the letter C, we're going to replace it. So we have 9/5. C is equal to 20. I'll leave off the units. And then we're going to add 32. And if we simplify this, the value we get back is the corresponding temperature, but now in degrees Fahrenheit. So you can do this in a calculator if you want to. We're just now following order of operation, but let's see. If I look at these two fractions, I can cancel a factor of 5. So I get that F is equal to, okay, so we have 9 times 4, which is 36, plus 32. And when we simplify this, F is equal to 68. And this answer is in degrees Fahrenheit. So those two temperatures are equivalent. They're just measured in different units. So I'll try this for the other two remaining temperatures, 100 degrees Celsius and negative 40 degrees Celsius, just to see what the corresponding temperatures are. So next, 100 degrees Celsius. Same idea. I will take our formula, F, and wherever I see the letter C, I'll put in 100, and then add 32 at the end. Same approach. I can, let's see, create a fraction here. And, 5 again, it goes into itself once. It nicely goes into 100. We get 20. And going back, we just need to simplify this down to one number. And again, you can type this into a calculator. There's nothing wrong with that. So let's see, F is equal to, we have 9 times 20, so that's 180, plus 32. And simplifying that gives us 212 in degrees Fahrenheit. So maybe just to be more explicit for this one, if you say 100 degrees Celsius, that's the same thing as saying 212 degrees Fahrenheit. And this is a nice reference temperature. In Celsius, 100 degrees Celsius, that is the boiling point of water, and corresponding to degrees Fahrenheit, 212 degrees Fahrenheit is also the boiling point of water. And let's see, for the last one, negative 40 degrees Celsius, same thing. It works for negative numbers or really any number you like, but F is equal to, okay, so again, it's 9/5. We have negative 40 plus 32. So here we just have to be a little bit careful because of the negative number, but we can still cancel in the same way. That is, okay, I know I can just write it as 5 goes into itself once, and it goes into, well, 40, that's going to be 8 times, but really that's negative 8 times 9 this time. So let's see, F is now equal to, well, 9 times 8 is 72, so this is negative 72 plus 32. And the result here is that F is equal to negative, it's got to be negative since the negative is on the larger number, negative 40. So this is interesting. Here you have negative 40 degrees in Celsius converted to Fahrenheit is actually also negative 40 degrees. This is the only temperature between Celsius and Fahrenheit where this happens. So again, basic idea, if you have an expression, you're plugging in one number and solving for the other. In example 2, so here's just another formula that has a little bit of context. Here I have the graph of a triangle, and here the area of a triangle is given by 1/2 the base times the height. I'm going to label a few things on this triangle. When we say the base, that would be the length of the bottom. And height, you have to be a little bit careful. If we're calling this bottom portion the base, and there's a lot of ways to get to the highest point of this triangle, but only one of those ways represents the height. And that is going to be this distance here, the one distance that is at a right angle from the base. So if the base is the length along the bottom, then h is going to be the height. So at this point, I haven't given any values for the base or the height, but let's just say that the base is equal to 15. Maybe we'll say inches. I know it's maybe not to scale here. And we'll say maybe the height is equal to 12 inches. If these were the values for the base and the height, what is the area of this triangle? So I'll substitute this in. Here we have two different variables, but the area, A, is equal to 1/2. The base is 15, and the height is 12. And easy enough to, you could do this right in your calculator. You could call 1/2 0.5. I'll simplify it just a little bit differently. Let's see. If I put 12 over 1, it just so happens that 2 goes into itself once, and it goes nicely into 12 6 times. So the area is going to be 15 times 6. Okay, and when we multiply that out, that is 90. The question is 90, well, 90 what? If we're being a little bit more careful, going back to the previous step. So 15 is actually already above here, but that's 15 inches. And 6 is also 6 inches as well. So if you multiply these two numbers together, the result is going to be inches times inches, which is the same thing as saying inches squared. So a unit squared, so if you're measuring distance and you square it, now you're talking about an area, the amount of space something takes up. But this would be the answer to the question, 90 square inches. And for the last example, example 3, again, if you want to find the volume or area of some given object, and here we have this formula, let me highlight that. V is equal to pi r squared h. This is saying that the volume of this cylinder is equal to pi times r squared times h. Here, r represents the radius of the circular top, so I'm going to draw that in here. So the radius meaning you start at the center of the circle and go out to, well, any point on the outside circle. Maybe try to make this look like it has 3 dimensions to it. Now the height, same thing as last time. Height is going to be, if we go from the top down to the bottom, but at a right angle. So here this is h. So these two dimensions, r and h, are enough to figure out the volume of this object. Maybe one thing to note is, for pi, we're going to use the approximate value of just 3.14. So this means since we're not using the entire value, our answer is only going to be approximate, but it'll be a good approximation. So let's say that the radius is equal to 6 centimeters, and the height h, we'll say that that is maybe 17 centimeters. So this problem is going to be a lot like the previous one. Here we have 2 variables. I'm just going to make a substitution and simplify it. So I'll do that below. Okay, so I'm just going to put 3.14 in place of pi. Okay, r is equal to 6, and I'm going to square it. And maybe this time I'll actually leave the centimeters in here. And finally for h, that is going to be 17, and I'll put centimeters as well. So this is it. This is the volume, but I think we should probably multiply all these numbers together. And I'll be careful with the units too. So simplifying a little bit further, we have 3.14. Okay, if we square out 6, I know it yields 36, but squaring centimeters is going to give us square centimeters. And I've not done anything with this 17 centimeters. So here I'm just following order of operation. Since there's no exponents to deal with, this is just direct multiplication. I think at this point, all we have to do, we can multiply the 3.14, the 36, and the 17. And the only thing that remains after that is going to be, well, we have centimeters squared being multiplied by centimeters to the first. So I'm going to multiply in a calculator the three numbers together. So that's 3.14 times 36 times 17. Okay. We get that V is equal to 1,921.68. And since we have a centimeters squared and a centimeters to the first, that gives us centimeters cubed, or cubic centimeters. And this is the final answer.